Hello, and welcome to a short lecture on the use of case classes in Scala. So, up until this point, we have been using case classes, or we've been using tuples when we want to group data. For example, if I were keeping track of a person and with their name and their age, I might do something like this. And the tuple here holds a string and an int. This, in some sense, works fine, but it does have some shortcomings. For example, how do we get things out of it? Well, one way for doing that is using the _1, _2, etc. methods. Another method of doing this is to do an assignment into a tuple. Now, this first method, while being shorter, especially if we only want to get one value out, has the significant downfall that _1 is not very informative to us. It doesn't tell us anything about what we're pulling out. This version here winds up giving us a useful name to work with, but unfortunately it's very easy to mess up, and also the type string int, this could be a person's name with their age, it could be a student's name with their score, or student ID with their score, it could be a fast food chain and how many stores they have open in the world. There are many things that could be represented by a string and an int. And so the use of tuples for all types of joining winds up not being very readable and not being very expressive. So the alternate way that we deal with this is to group data together in what are called classes. And we are going to focus in particular on case classes. These are declarations. So we've previously seen that we can use val or var or def to declare either variables or functions. Here the keyword is class for the declaration, and we're going to modify it using the case class just because it will provide us for certain functionality for the purpose of grouping things together. So if we make a case class, for example, of a person, as we're looking at here, the person has, in this case, two types of information associated with it, a name and an age. In doing that, we have created our own type. And just like int is a type, and double is a type, and tuples were types, and array of int was a type, and list of array of double is a type, we've just made a new type that is all ours, called person. And because it is a type, that is why this was started with a capital letter. Normally when we declare variables or when we declare functions, we use lowercase letters, but all of the types that we use in Scala, string and double, all start with capital letters, and it's good to follow that in your own coding. It helps prevent things from getting confused. So given this declaration, we can now make a new person with a name and an age like this. So we've declared a variable called Mark, and the syntax for instantiating an instance of this case class is just to use the name of the class and follow it with an argument list, where just like if we were calling a function, first argument is there, second argument is there, so the name becomes Mark and the age becomes 38, and you can see this prints out nicely here. To get values out, whereas with tuples, no matter what tuple you write, the first element is _1, the second element is _2. The advantage of tuples is that we pull values out by using the name of the field. So this informative, useful name that we gave here in the declaration, and hopefully you do choose names that are informative and useful, is the one that we use in the program. And this helps make the code much easier to read. If you come back to a piece of code later, it's much easier to know what name means than it is to know what _1 means. And quite honestly, the _1 and the _2 aren't that bad if you only have one type of tuple that you're dealing with. But if you had one tuple that represents a string and an int and another one that represents double, 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 and you're using them interchangeably inside of a single function, ._1 will mean different things depending upon what you're pulling them out of. And so this winds up being far more useful to us. Another example might be a case class for a vector. X is a double, Y is a double, Z is a double. And if we were to make one of these, we could do so like that and then pull values out. We could also write a function called magnitude that takes a vector and it gives us back a double. And the value of that would be math.square root of Vx times Vx plus Vy times Vy plus Vz times Vz. Left off a close. Is that thing double? Oh, sorry. Typo. In, close. Guess I didn't need that extra close. There was my problem. I had the extra open in there. Okay. So now we have a function for magnitude, and we can call the magnitude of the vector v that we made up here 1, 2, 3, and that is the magnitude of that vector in 3 space. It's always nice to call functions with things that you know the answer to. So how about a vector of 4, 3, 0, and this has a magnitude of 5. So this is a simple example of the usage. We can do a further illustration by returning to a data file that was used in the previous chapter. And in fact, we will use the same techniques that we did in the previous chapter. Here we have a box score, and we're only going to keep certain columns out of this. So if we have their name, how long they played, shots made and attempted, three-pointers made and attempted, free throws made and attempted, their plus minus, their offensive rebounds, total rebounds, etc., 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 down here to points at the end. We're not going to represent all of those. So let's go ahead and let's make a file. Because we're going to read this from file, we are going to import scala.io.source. And we want to declare a case class that represents a player, a single line from our box score. I would like to keep the player's name. Let's see, minutes played, no, not necessarily. How about we keep track of shots, just regular shots made, which will be an int, attempted, which will be an int, rebounds, which is an int, and points, which is an int. And everything else will wind up throwing away from that data file. To break up the problem, I want us to write a function that will take a line as a string and give us back an instance of this case class. So I'll call it makePlayer, and it takes a line as a string, gives us back a player. And so we want to split up this input. As we saw in the previous chapter, this file has tabs inside of it. So how about we just call this P? We could say parts, but we're going to refer to multiple pieces of it. P equals line.split on tabs. Okay. And there are multiple approaches we could take. There's a short syntax where I could say something like P sub 0 right here and just build my player with all of these things in it. While it's a little bit more verbose, I think it's much easier to understand if we actually make separate variables for each of the parts. And in fact, one reason why this is helpful to do it this way is in the case of made and attempted. Well, these are two values here that are split, that are in a single value. So this is P sub 0, P sub 1. P sub 2 holds these, and so we need to split it on the minus sign. And so how about we call that shots equals P sub 2 dot split on the hyphen, and then val made is shots sub 0 dot to int, and attempted is shots sub 0 or sub 1 dot to int. Up next is rebounds. Well, so if this was sub 2, sub 3, sub 4, sub 5, sub 6, sub 7 is the total number of rebounds. P sub 7. Sub 8, 9, 10, 11, 12, 13, and 14 is points. Okay. So that gives us all the information that we need to build a player. So the last line in our function will build the player itself with name, made, attempted, rebounds, points. Now, the variable names that are used in here happen to match the ones that are up here, but that is definitely not required. Okay, this could have been N, S, M, A, R, and P, O, because I wouldn't want it to conflict with that, or P and T, S, whatever. Now, given that function, we can open up a source. So let's make a new val. I'll just call it source. From file, boxscore.txt. Val lines equals source.get lines. Make sure we close off the source. And now we can make players by running through all the lines, and for each line we want to pass it into make player. So we can simply do a map onto make player for each of those lines, and then down here we can do player dot for each print line to see what comes out of that. And let's see if that is happy Scala code. Nope, we have some errors in here. Type mismatch. Rebounds and points both need to be to int. And we have one more error, not found value player. That's because there it is plural, players. Ooh, that's always fun. So what happened here? Indeed. So this was, in some ways, you could view this as premature closure, in the sense that our problem is it says the stream is closed. In some ways that is definitely true for this. But it's not because we didn't want to close it here. It's because if we were going to use these players multiple times, we should convert them either to an array or to a list. And there we go. So we have all the players, they're in there, and we can now use the case class in the same way that we used a tuple, or actually we used an array of strings. If we want to calculate the average number of points here, we can print line players dot map of underscore dot points dot sum, and let's go ahead and convert. Actually, no, if I just want total points, I can just do the sum, and we get 116 points for this game. One of the big advantages of this, now in the last time we weren't using a tuple, it was just an array of strings, but even then we had a sub 14, which really wasn't very useful. In this code we still have, or it wasn't very informative, in this code we still have sub 0, sub 2, sub 7, sub 14, but they are in a position where it's very clear what they're supposed to be giving us. We're pulling stuff out, and then in the entire rest of the program we're always using the names points, name, made, attempted, so things that are helpful to us. So case classes, while they have more functionality in Scala, for now we are using them simply to group together pieces of data and to give them names that are useful to us, and also to have types so that Scala can help tell us when we're messing stuff up and do additional checks for us. And that's it for this lecture, and we'll come back and have more fun with case classes soon.